Okay, so this is the next part, 7b72. It's line 22, 7b72, magnetized proton pulses, UFO 5G Wow Seti. There's the alien radio signal. There's the line of data, 7b71, Helices, spectroscopy, proper interfaces. And this is about spin magnetized protons, PDF research results for core area of UFO spaceship. The previous video was Helices spectroscopy proper interface. SAMP14 is a pulse sequence. High resolution local field spectroscopy with internuclear correlations. Journals ohiolink.edu. Quotes PDF files from blogs. High resolution local field spectroscopy with internuclear correlations. There's the name of the scientist, and this is from Raleigh, North Carolina. dx.doi.org. Abstract: establishing correlations among distant spins remains an outstanding problem for both spectral assignment and elucidation of interhelical contacts in solid-state NMR of oriented membrane proteins. Here we present a pulse sequence which incorporates the previously established mismatched Hartmann-Hahn mixing of dilute spins via the proton back together with high-resolution local field spectroscopy. In addition to providing structural information, the use of dipolar couplings in the indirect dimension helps eliminate the spectral crowdedness compared to the standard homonuclear correlation techniques. The proposed pulse sequence may find its use in assigning protein spectra in unilaterally oriented membrane environments. The keywords are high resolution separated local field spectroscopy, intermolecular correlations, dilute spin exchange, and SAMP14. The figures and tables are from this article. Right here, two-dimensional pulse sequence for the high-resolution separated local field spectroscopy that simultaneously establishes internuclear correlations. Cross-polarization is used to enhance the magnetization on the 15N side. The SAMP14 pulse sequence, which is 180 degrees cycled between odd and even dwells, is applied to evolve the herterneuclear dipolar couplings. After the Z filter stored 15N magnetization is brought back along the x-axis, the mismatched Hartmann-Hahn scheme with the proton RF field above the CP match value is applied. Finally, the 15N chemical shift is detected under the conditions of proton decoupling. Experimental solid-state NMR spectra acquired with a single 15N labeled N-acetyl leucine crystal at arbitrary orientation using the pulse sequence. Gray contour lines are related with corresponding SAMP14 spectrum, black contour lines. The CP match RF field strength was 65 kHz. 3.85 us 90 degrees pulse, 64 T1 points were acquired in the indirect dipolar. Dimension A2S filter was applied, and the mixing time under the mismatched Hartmann-Hahn conditions was 7 ms. During the mixing, the proton RF amplitude was set to 70 kHz. At 8% above the CP match, 128 transients were acquired in the T2 dimension with 6-second recycle delay. A Brucker 3.2 nm mass probe was used without the rotor spinning. Profiles of the maximum quasi-stationary transferred magnetization between two 15N spins mediated by the proton network as a function of the Hartmann-Hahn mismatch. The simulation solid line was performed as described in the text. The left vertical axis was normalized relative to the initial magnetization of the first spin. Note the asymmetry in the profile for the transferred magnetization relative to the exact CP match. Circle dashed lines show experimental intensities for one of the cross peaks at 142 ppm. The experimental intensities were uniformly scaled to best match the simulation. Arrow bars correspond to the noise level in the two-dimensional spectrum. Slices through the indirect dimension for the peak at 95 ppm obtained using the pulse sequence of figure 1. At the 8% mismatch above solid line and below dashed line relative to the CP match conditions, other experimental conditions were as described in the legend for figure 2, www.sciencedirect.com. And the next keyword will be solid state NMR is what I'm going to be looking at. So I'll go back here. Okay, and thank you for watching.